Today we're going to be talking about graphing systems of inequalities and what's entailed with that. So here we have two inequalities in the form of y is less than or equal to 3x plus 2 and y is greater than negative x plus 4. So let's go ahead and we'll start off by graphing the lines. With this, the first one, y is greater than or equal to 3x plus 2, we're going to use what's known, well, we're going to use a solid line. And because that's going to show us that anything on that line is going to be a solution. So let's see, let's start off by plotting some points. So we start at plus 2. And then we go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. And let me get one more point, but in the other direction. So down 3, 1, 2, 3, and left. We'll connect our points. Make sure your lines extend the entirety of your graph. Okay. All right, now we're going to look at our line here, and we need to figure out what this inequality means and how we represent it. So this is simply stating that, in fact, values of y, or solutions, are values of y that are less than 3x plus 2. So that means any value of y that's less than this line represents 3x plus 2. And the y values, we want y values that are less than that. So we ask ourselves, which direction is y going to be less than compared to the line? Well, as we know, on the number line, the vertical part, y gets less than as you go down. So like we have -1, -2, -3, so forth. So that means we're going to shade everything below that line. And the reason that we used a solid line is that anything on that line is a solution. Because remember, we said that if you're solving equations, then solutions to an equation is going to be anything or any point on that line. You can take any point on the equation line, substitute it in, and you'll get a true statement. All right, so that's good enough. All right, now we're going to look at the next inequality. So y is greater than -x plus 4. Now, notice, well, we're going to graph this just like the other one. Before I get ahead of myself, 1, 2, 3, 4. So there's our y-intercept, and we go down 1, over 1, down 1, over 1, and down 1, over 1. Okay, so notice that this one lacks the equal to part. It's just a greater than sign. So that means any solutions on the line or any point on the line is not a solution. So we must use a dashed line representing, there's a limit here, but does not include the line itself. All right, so we want to figure out, well, what side do we shade on this one? Well, since y is greater than -x plus 4, So this line represents negative x plus 4. We ask ourselves, for which values, or where does y get greater than? Which direction, up or down? That's how I want you to think of it. Do you shade above the line or below the line? So if y is less than, then you shade below. And if y is greater than, well, you shade above, because y gets greater the further up you go. So I would suggest that you use a different color when you shade this, or if you shaded one way here, you can shade like maybe using horizontal lines in the other one. You can use vertical, horizontal lines if you just only have a pencil or a single color pen. And so we're going to get everything above this line. So some of it's going to be outside of the shaded region for the first one. Some of it's going to be inside. But we want to get everything, because all of this stuff is, in fact, a solution. Now, you'll notice it's a different color where they overlap, because I'm using two different colors. And any point, basically, in this shaded region is a solution to both. So basically, if I were to pick a point, let's say like here, any point in this yellow region, here or here, is going to be a solution for the first equation or inequality. And anything in this blue region is going to be a solution for this one. So if I pick just this point here, then it will work. It'll get a true statement for the yellow one, but it won't work for the blue, for the second one. And if I pick a point up here, it will be a solution for the second inequality, but it will not work for the first. So your solution region to the system is any point in this green area. And we can test that by picking a point and seeing how it goes. So let's see. I want something easy to work with. So I'm going to pick this point right on the x-axis. So that's going to be 1, 2, 3, 4. So that's going to be 5, 0. And let's test this point. Let's see what happens. Okay, so for the first inequality, where we have y is less than or equal to 3x plus 2, I'm going to plug in 0 for y is less than or equal to 3 times 5 plus 2. And that's going to leave us with 0 is less than or equal to 15 plus 2 plus 2. And 0 is less than or equal to 17. Is that true? Is 0 less than or equal to 17? And our answer to that would be yes. Okay, so let's works for the first one, but what about the second one? So it's 0 is greater than negative 5 plus 4. 0 is greater than negative 1. Is that true? Yes, it is. So we can see that this point here is a solution for this system of inequalities, as is any point in this overlapping region. Okay, now let's look at another one that's slightly different. We're going to graph this system here. We have a absolute value function, and then we have another linear. So let's start with the absolute value. All that's happening here compared to the parent function is that it's being shifted to the right one. But as far as like each of the branches, it's going to be the same as the parent function. So the right side is going to have a slope of 1, the left side is going to have a slope of negative 1. So we're just going to shift right 1 on the origin. It's not going up or down. So then we go up 1 over 1, up 1 over 1, up 1 over 1. And then this side, left 1, up 1, left 1, up 1, so forth. and it's greater than or equal to. So that means we're going to use a solid line. So it's going to look like this. And this. Now we ask ourselves, which side do we shade? Well, it says that y is greater than or equal to. So we ask ourselves, well, which direction is y greater than? And that's up. So we shade above the function. So that's going to be everything above it. So that's going to be all of this here. Okay. Now, let's graph the next one. Now this one is linear. There's no y value, it's just x is greater than 2. So recall that if you have just x is equal to a number, that's going to be a vertical line with an undefined slope. So, and we're going to be using a dashed line. So let's see, we're going to start at 2, so all the values of x should be 2. And so it's going to be right here along 2. This way and this way. Okay, now as far as shading is concerned, this is going to be the only exception as far as determining how you shade, because you can't shade above or below a vertical line. This is the one case where you're going to consider shading left or right. So we need to think about what it's telling us here, and it's saying that x is greater than 2. So looking at a vertical line, we say, well, which direction is x greater than? Well, it gets greater the further we move to the right. So we're going to shade everything to the right of this line, trying not to cross the line. So it's going to be this whole region here. And this kind of gives you a chance to break out those elite coloring skills you've been developing since preschool. My skills are not elite at this. I've always kind of struggled at coloring because coloring is hard. I can't stay within the lines. I guess it's because I'm such a rebel. All right. So now, we can see that any point in this region here is going to be a solution to the system. It'll work for both. But I want to experiment. I want to test, let's say, a point that is in the yellow region, but on our vertical line. So let me go ahead and I will do, let's try this point here. So this is the point 2, 4. Now it's right on the vertical line. So what I'm going to anticipate happening is it's going to be a solution for the first inequality for the absolute value because it's well in the yellow region, but it won't work for the other line because it's a dashed line, and so anything that's dashed, any point on the dashed line is not a solution. It has to be solid for that to work. But let's verify this. So we'll start off with the absolute value. So 4 is greater than or equal to 2 minus 1, the absolute value of 2 minus 1, and 4 is greater than or equal to, so this is going to give me the absolute value of 1, which is just 1. So 4 is greater than or equal to 1. So that clearly works, as we anticipated. Now, the next one, I'm going to substitute this into the x. Now, there is no y, so the only thing I can substitute into there is the x. So 2 is greater than 2. Well, 2 is not greater than 2. That does not work. So that would not be a solution for the second inequality. Now, had this been a greater than or equal to, then we would have drawn a solid line, and then we've said, oh, okay, well, yeah, that's a solution. So that's why we use a dashed line versus a solid line for those points that are on the line itself. Anyway, that concludes graphing systems of inequalities, and I'll see you in the next video.